Hello students, hello everyone. This is Senior College Mathematics. Topic of discussion is simultaneous linear equations. Simultaneous linear equations. Lesson 5. Substitution method of solving simultaneous equation 2. So lesson 5 is the continuation of lesson 4, where this method started from. So examples: solve the following equations using substitution method. That is the instruction. Before that, for updates, follow Voice of Petakus via YouTube at PetakusEduCom. To do that, subscribe to this channel, like and share this video to your friends, your classmates, your colleagues. Facebook, fb.me/PetakusEduCom, Instagram at PetakusEC, Telegram t.me/PetakusEduCom. In all of these platforms, you get updated from time to time about what is happening at Petakus Education community, where you have access to quality, unlimited and simplified mathematics teachings. Okay. Example 9. Solve simultaneously using substitution method. 4 over a minus 3 over b equal to 18. 2 over a plus 5 over b equal to minus 4. What you have here is not different from lesson 3, but we want to use the method of substitution here. Alright, like I explained in that lesson, if you try to clear the fractions by multiplying through by the LCM of a and b, you will have a non-linear equations which you cannot solve simultaneously. Since the unknown is at the denominator, you try to factor it out such that you write 4 over a as 4 times 1 over b times as 4 times 1 over a. Then you write 3b as 3 times 1 over b. If you come here, you write 2 over a as 2 times 1 over a. You write 5 over b as 5 times 1 over b. You need to relax 1 over a and 1 over b so that you can solve the equation. When you are done, you solve for a and b. So let s equal to 1 over a and y equal to 1 over b. After factoring out 1 over a, 1 over b across the two equations. So you have 4s minus 3y equal to 18. You have 2s plus 5y equal to minus 4. By this method, let us recall equation 1, that is 4s minus 3y equal to 18. I want to make s the subject, hence you have to transfer minus 3y to go and meet 18, which become 4s equal to 18 plus 3y. To get s, divide both sides by 4. So s is equal to 18 plus 3y all over 4. So you call this equation 3. So it is equation 1 that produced equation 3. The rule is that you have to substitute equation 3 into equation 2 to continue. So you recall equation 2, that is 2s plus 5y equal to minus 4. Where you see s, you replace it with 18 plus 3y over 4. That is what you have here. Then plus 5y equal to minus 4. The way it is, these two can divide 4. So you are left with 2 as the denominator. So let's proceed. That is what you have here. After that division, you clear the fractions by multiplying through by 2. So you multiply this term by 2, you are left with 18 plus 3y. Multiply 5y by 2, you have 10y. Multiply minus 4 by 2, you have minus 8. So here, if you add the like terms, 3y plus 10y, you have 13y, and transfer plus 18 to the right hand side, you have minus 8 minus 18. You see that? So you have 13y equal to minus 26. To get y, divide both sides by 13. So y is equal to minus 26 divided by 13, and that is minus 2. Next thing is to solve for s. So you substitute y equal to minus 2 into equation 3. Equation 3 is s equal to 18 plus 3y equal to 4. Where you see y, you put minus 2 in this form. So you have 18 minus 6 over 4. That is 12 over 4, and that is 3. Meanwhile, you were not asked to solve for s and y. You only introduce s and y to make the equation solvable. Then you look for a and b. So you recall that s is equal to 1 over a. 1 over a. If you make a the subject, a is equal to 1 over s, and s is 3. So a is equal to 1 over 3. You also recall that y is equal to 1 over b. If you make b the subject, the initial variable in the original equation, b is equal to 1 over y. And what is y? Minus 2. So b is equal to minus 1 all over 2. The minus sign can be anywhere. So it can be minus 1 over 2 or 1 over minus 2. You are saying the same thing. So this is how you solve this type of equation once again. Okay. Example 10, you have 5s minus 3 over y equal to 1, and s plus 4 over y equal to 5 over 2. This is like example 9, but y is the only unknown at the denominator. So if you factor out 1 over y from both equations, you have 3 times 1 over y, then 4 times 1 over y. So you only replace 1 over y with another variable. So let's say m is equal to 1 over y. If you replace 1 over y by m in equation 1 and 2, you have 5s minus 3m equal to 1, and you have s plus 4m equal to 5 over 2. Okay. Looking at it in equation 2, variable s has coefficient of 1. So let's recall equation 2 and make s the subject. Okay. From equation 2, which is this, to make s the subject, you have to transfer plus 4m. It becomes minus 4m. So s is equal to 5 over 2 minus 4m. Okay. So let's clear the fractions on the right hand side now. So the LCM is 2. So you have 5 minus 8m over 2. You know, you write 4 now as over 1. The LCM is 2. So you divide 2 by 2, you have 1. 1 times 5 is 5. Divide 2 by 1, you have 2. Times minus 4, you have minus 8. So s is equal to 5 minus 8m over 2. You call this equation 3. To proceed, equation 2 produced equation 3. You have to substitute equation 3 into equation 1. I'll be emphasizing this rule when using substitution method. Okay, so this is equation 1. Anywhere you see s, replace it with 5 minus 8m over 2, what you have here now, minus 3m equal to 1. Nothing is common to 5 and 2, so you have to open the bracket by multiplying the numerator by 5. So you have 25 minus 40m over 2 minus 3m equal to 2. To clear the fractions, multiply through by 2. If you multiply the first term by 2, you have 25 minus 40. You multiply 3m by 2, you have 6m. Multiply 1 by 2, you have 2. So, as you will add the like terms, also transfer the constant term 25 to the right hand side. So, minus 40m minus 6m, you have minus 46m. Then if you transfer 25, it becomes 2 minus 25. And minus 46 is equal to minus 23. To get m, divide both sides by minus 46. So m is equal to minus 23 over minus 46. In this case, when you are dividing a smaller number by a bigger number, your answer is always fractional. So what can divide 23 and 46 without remainder? That is the HCF is 23. You divide 23 by 23, you have 1. Divide 46 by 23, you have 2. Note that if you divide a negative number by a negative number, the result is a positive number. Okay? Now that we know n, we have to solve for s, and we recall equation 3 where s is already the subject, and it is this. Where you see m, you put 1 over 2. See that? You divide 8 by 2. In other words, 8 times 1 divided by 2 is 4. So you have 4. You have 5 minus 4 over 2, and that is 1 over 2. So therefore, m is equal to 1 over 2 and s is equal to 1 over 2. But we need y. Y is the unknown variable in the original equation. Because we cannot solve it directly, we have to introduce m to help us proceed with the solution. Okay? Recall that m is equal to 1 over y. If you make y the subject, y is equal to 1 over m. This is a value of m now, 1 over 2. If you divide 1 by 1 over 2, you have 2. Finally, s is equal to 1 over 2 and y is equal to 2. You see that? So this is how you solve simultaneous linear equations, whether in fractional form or in linear form. Alright, end of lesson 5. Thanks for watching and learning with PetakusEducation community. Watch out for more from the voice of Petakus. For questions, for inquiry, contact the voice of Petakus via this WhatsApp number or through the email address. For the complete package of this topic, simultaneous linear equations, lesson 1 to 9, for offline users, you can also contact him through the WhatsApp number or the email address. At a very little token, you get the complete package delivered to you. Lastly, if you are not saved, you need to be saved. And the only way is to give your life to the Lord Jesus Christ, because He is the only one that has the power to save anyone. If you are saved already, I tell you, big congratulations. Live righteously and be prepared. On the last day, some will be taken and some will be left. Take very good care of yourself. Stay out of trouble. Stay well. Study your books. Do the needful at all times. And goodbye for now.